In next 40 minutes you will learn how to simulate rocket engine fire in 3D Max and why it has so much in common with nuclear power plant control. My name is Alex Andrew, you are on my channel and watching a rocket engine flame tutorial. Generally speaking, all we need to do is to guide our flame from the nozzle in a straight line with some tapering in the end before it disappears. Additionally, we need to keep the flame stream stable and clean. Meanwhile, inside the fire we must to keep certain Mach Diamonds pattern. Honestly, I could make easily this tutorial 3 minutes long just by giving you the right values, but you will most likely fail if your scene conditions are even 1% different, since the system is extremely sensitive, although simple. So I decided to show you my clean attempt from an empty scene with all troubles that I will face and how I solve them. In case you really want those final values and nothing else, just jump to this timing and you will find a quick settings overview. But in an hour I guarantee you will come back to watch the whole tutorial. First thing, always check units. Must be as centimeters, 1 unit equals 1 centimeter. For this basic tutorial we need a minimum geometry object. This one is the most crucial, a rocket nozzle. Its shape will affect simulation a lot, so to match your results under the same values, make sure you will create a similar one with the diameter around 60 centimeters and the side shape just like I'm doing, this kind of tapered cup. So let's add some mesh smooth and shell, and pretty big shell, because we don't want our voxels go through the mesh. The second geometry we need is an emitter object to emit our temperature. I'm using this basic cylinder object. You need just to place it just in the middle of the hole in the nozzle. We don't need too much polygons, but we need to adjust the shape. We can taper the top side and delete the back polygon, because we don't want to spray our voxels from the back. Also we can mesh smooth it, something like this. Now we are ready to create our simulation box. Small size for the beginning, just to cover the nozzle volume with some extra space in front and a little bit from the sides. All settings we will leave by default, and now we will create a source helper. We will leave its values also as default, just add an emitter object as a target. And it is good to give a proper name. Now we are ready to try our first test simulation. Just make a cashless and check if everything works correct. Now we will go to set basic simulation values that I suggest to start with, and the first one is a speed. 3.5 is a good starting point. To balance the speed we need steps per frame somewhere from 6 to 12. I set 6 and change the method to forward transfer. Fluidity quality is 2 and we need to change method to direct smooth. I noticed that our emitter object is a little bit small comparing to the nozzle diameter, so we will increase a little bit the size and make more tapered. And we need to change the nozzle hole also to match the emitter object. Yes, just like this, and a little bit forward, move it forward. So now it is looks better. We can try our simulation test. Everything works fine. And the last value that we need to change from the basics one is gravity. We need to set it to 0. We don't need gravity for the flame simulation. And now it looks correct. Our next step here is to create a path follow helper. Let's place it here above the simulation box. And in addition to this helper, we need to create a line that will guide our flames. Start somewhere from the middle of the nozzle and the second point outside. And we need to place it just in the middle of the object. Okay, correct. And now we need to add this line to our helper as a target. And now it's time to set its values. For the start, I suggest to set follow speed 200, pull speed 500, rotation speed we don't need for this tutorial at all. Influence we can leave for now as 0.5, subsegments 1, max distance 70. Fade start I would suggest 0.1 as a start, and pipe radius around 35 comparing to our nozzle radius. Effect, let's leave only temperature channel. Now it's time to check with the simulation how it works. Okay, now we can see that our voxels goes along the guideline. Let's add some more velocity. 250 will be enough for now. Okay, good. Now we need to change our visualization parameters to see better what we are doing. So turn off the smoke, and in the fire let's adjust fire multiplier and physically based parameters, and turn on GPU mode. So now we can see only our temperature channel. Also, let's make our grid adaptive, and with these parameters, as you see, by the smoke and some additional size, especially in front of the nozzle. So we need some more space for our flame. And let's change our voxel size to 1.4 to make it a little bit faster. Okay, now we will gamble with our parameters really a lot. So let's make more aggressive parameters. For pull speed 1000. Okay, follow speed 500. Okay, 1000, 2000 for follow and pull speed. Let's add some velocity also, 1000. We need to go step by step. 4000, just until it will break. Max distance, also a good value to play, 60, 50. Okay, 6000 for pull speed, 2000 for follow speed. Watching. Okay, we reached this point. This is our nuclear reactor meltdown. Sometimes a restart helps. No, we are still in trouble. 1700. Still broken. Influence 0.4. Let's change also our steps per frame. That will give us more room to play, because the system will be more kinda stable. Okay, 10, it actually doesn't help, so 11. And temperature surface should be 0 for vorticity as well. Max distance 30, 2000 for follow speed. Let's restart our simulation, and now it looks fine. Alright, now our flame stream seems clean and stable, and now we can stop the simulation, and let's go to the visualization parameters and adjust this graph to see more details inside our fire. These adjustments are more like intuitive rather than some certain suggestions. I can say that I was just focusing on the right side of the graph around 1.5K temperature, because this temperature related to our center point of the flame stream, where we're supposed to see our Mach Diamonds, this effect that occurs with this kind of engines. Also, I tried to change the color. I decided to go from the white, warm white color at the high temperature and to the blue color at the low temperature. I'm not sure is it really realistic for this kind of engines, but I just like how it looks on my render. So let's adjust the rendering settings and let's try to see our frame buffer, how it looks. And honestly, I still cannot get the right points of these settings to see our Mach Diamonds. Probably we need to adjust the simulation more, because it's still not what we need. Now let's go back to our path follow helper and try another settings. Influence 0.65. Okay, 0.85. Okay, we see some changings, but still not what we need. Maybe max distance 25. Okay, it made it totally smooth, so let's go back to 30, 35. Okay, it is more sharper. This parameter is very tricky. Max distance is good for final tuning, but not for our current position. Influence 0.7, 0.55. Okay, seems like maybe more velocity, 2000. Seems like something is missing. Let's change a little bit more. Visualization graph. Yes, it's still not working as I was expecting. Something is still missing, some parameter. Let's make influence 1 maximum. Okay, maybe fade 0.2, 0.5. Okay, our flame is getting weaker. Influence 0.45. Let's try to move our guideline, maybe it will help. Okay, now it looks more interesting. Let's play with parameters again. Fluence 0.8, max distance 100, just for a test. Okay, let's go back 35. I think our final for max distance will be somewhere around 35. Influence 0.1, max distance 30, 32. Yes, this is our sweet point, I guess, for this parameter. 34. Okay, this looks much better. 35. Yes, we clearly can see our Mach Diamonds, or at least some pattern inside the flame. Influence 0.5, maybe pipe distance, pipe radius, sorry. Pull speed 6500, influence 0.7. It's still like a gambling, but we are approaching to our desired effect. Let's give some more room for our simulation. Okay, now it looks much better. Okay, 7000 for pull speed. This parameter will increase the distance between Mach Diamonds. Alright, the render looks better than before. Let's keep going with our parameters. Let's try pull speed 8000 to stretch our distance between Mach Diamonds even more. Influence 0.65. I think we are getting closer to our to our desired effect, cooling 0.1, to cool down our temperature a little bit faster. Okay, maybe we can play with our guideline a little bit. Okay, I see there's no significant effect, so let's go back and don't touch our line for now. Let's check the render. Okay, I think we need to adjust more our graph. Okay, we need to make our Mach Diamonds more separated from our flame stream. Okay, let's drop these 2 points maybe below the 0 level, so we will cut a little bit flame just right after the nozzle. Yes, this area. Now let's try render with motion blur. 0.5 for the start. Well, it's too much. 0.2. Yes, it is better, more smooth. And now let's restart our simulation, and maybe more pull speed, 9000. I will try to stretch our simulation and increase the distance between Mach Diamonds. Also, we can change steps per frame from 11 to 10, so it will make more distance between Mach Diamonds, or decrease the amount, the quantity of these diamonds. Maybe let's try another fluidity method. Okay, I think direct symmetric is not our case. I think we need to go back to direct smooth. It works better. Yes, definitely. So we will leave this method. Maybe quality 4. This parameter is also very tricky. It changes the look of the simulation quite a lot. Okay, let's try pull speed 11,000 to pull our flame closer to the line even more. Maybe max distance 33. And it will create some additional flames around the main stream, and it looks actually good. We just need to separate them with the color. That will be a little bit later. Let's change our cooling speed as well, increase it to 0.15. Okay, let's decrease our follow speed to 1800, and let's start a new simulation and check. Alright, our flame looks good now. Let's try maybe influence 0.85, and the follow speed change to 1500. Okay, maybe max distance 34. No, our flame is getting weaker. Maybe increase velocity to 4500. Okay, maybe let's try one more time to move a little bit our guideline. Okay, this is too much. Let's go back a little bit. still, I guess, too much chaos. This looks too broken. So maybe let's go just a little bit more, but still not as it was before. Okay, it is a good idea to make a backup safe at this point, but in my case I will just keep going. Let's try a quality test, maybe 8. Okay, I think we shouldn't go too far with this parameter. Let's keep 4 as before. Maybe max distance 36. Okay, it is making our flame a little weaker, but we can balance with the follow speed 2000. Alright, let's make quick readjust our visualization graph according to our new simulation. Maybe we can find better spot for this graph. Okay, let's try to render this out. Cannot say it is better, but we will adjust it. We will keep adjusting. So let's maybe try pipe radius 40, maybe 35, and let's adjust pull speed to 16,000. Alright, maybe let's make longer guideline. Okay, its effect is very little. Influence maximum 1. Maybe max distance 35. Yes, this is better. Let's try to check with the rendering. Okay, good. We will keep going with our parameters. Pipe radius 50. Okay, maybe max distance. Maybe 40. Or it's too much. Well, let's keep 40, but influence 0.9. Okay, let's go back with max distance to 38. 40, that was too much. Let's check with the rendering. Okay, still a little bit not what I need. Let's try influence 0.5. Okay, maybe 0.45. Okay, I see our flame is falling apart again. Yes. Okay, let's go back to influence 0.48. Let's try just to restart simulation. Okay, it works fine now. Maybe 0.45 for influence. Okay, our flame is still stable. 43. Alright. Max distance 36. Okay, stable and looks better. Good, now we can pause our simulation and try to render. Let's make a color separation for these flames around around the Mach Diamonds. Yes, something like this. Okay, maybe adjust our graph a little bit more, just in case we can find a better spot. Okay, this keeping below the red level gives us a nice effect when the flames next to the nozzle is kinda more transparent. Alright, let's quickly make a test if quality 2 works better. As you can see, the fluidity quality value is changing our pattern. The look of the simulation is really a lot. Actually, I like it, but we will keep playing with the settings. Okay, let's go to our helper and let's adjust a little bit more. Okay, fall speed 1700, pull speed, let's make it 17,000. Okay, max distance 38. Okay, our flame seems like collapsing again. Yeah, it's falling apart. Let's change our fluidity, maybe 3, and without uniform density. Okay, restart simulation. Steps per frame 8. Okay, good. Keep going. Max distance 40. Okay, better. We see clearly our Mach Diamonds. Maybe 39. As I said, max distance parameter is very good for final tuning when all the rest of the values are kinda final. Alright, our next step will be to make output for our cache, because before we were working in cashless mode. And let's give some more room for our simulation from the sides, like 50 additional points. The height 40, and the length of our simulation box significantly bigger. And let's run our simulation. So we will have more cache to make a preview. 74 frames I think is enough. Yes, so let's run a quick preview and check our simulation on a video. Alright, here's our preview. It looks really good. The only thing I would adjust is this blue flames around our stream are kinda slow, so we will speed up them with additional helper, the plane force, so we will blow those blue flames a little bit faster. Okay, we don't need to add it in the list because everything in the scene is affecting our simulation. Let's adjust values for this helper. So the wind strength is 1000. Affect channel only temperature. And what about max distance? So for that we will make a quick measurement now in a scene with the simple plane object, and we will measure the approximately distance where we want to affect our wind on the flame. So it's something around 750. So just input max distance 750. Alright, and let's save the scene and run another new clean simulation. As you can see, the blue flames are moving faster. I paused my simulation in the middle so we can compare our new cache and old cache, and we can see the plane force effect. So our stream looks more pretty, more compact, less chaotic. And now let's check how it looks on the render in the frame buffer. And it looks good. Our Mach Diamonds looks very sharp, nice, and flames, but brightness and colors are kinda messy, so we will adjust them. Our smoke is off, and we will focus on our temperature parameters. So let's adjust my my panels on the screen so we can work more comfortably with this graph. So let's try our rendering, and first of all let's adjust our gradient, the colors. I want to make it a little bit more warm next to the nozzle, more punchy. Yes, something like this. The cold colors we will adjust a little bit later. Now we will focus on the right side of the graph with these 2 points below the red level, so we can play with this little gap, opacity gap next to the nozzle mesh, which I think looks pretty real. And as I mentioned before, the adjustments of this graph are more like intuitive, so you can just play with these points and the shape of this graph, just to find the better look of your simulation. Because every time you have a new simulation, you will have to readjust this graph to squeeze more information from your cache data to visualize your Mach Diamonds pattern and the flames. Now I think we need to adjust the light emission from our flame. Let's try 30, 20, maybe 10, 5. We need to make really bright inside part of the nozzle, because our flame is emitting a lot of light as well. Another thing that we need to adjust is opacity of our flame tail. With this texture slot, we will place a V-ray distance texture. And let's swap these colors and add our nozzle as an object. And all we need is to adjust our distance where our opacity will be lower. So we can take the distance from the wind and adjust and add a little bit more. So something around 950 centimeters. Is a good value for the distance to dim opacity of our flame. And as you see now, the tail is more transparent, so it has less focus, less attention. We will adjust a little bit more later. Now I think we can go back to our graph and play a little with these two parameters, physically based value for the fire opacity mode. Okay, let's try 0.2 for this value, because we need to keep the brightness of our fire stream. we still can adjust our graph. Okay, now it looks better. Let's try a whole thing to render. Looks nice actually. Next thing that we will work with is maybe brighter the cold, the lower temperatures, like these blue flames, make it a little bit more visible. Yes, something like this. So we have a nice contrast. Maybe decrease distance to 900. So we will still see these flames, but not as transparent. Also, another trick is to put this map inside the output map and adjust graph also here to make more contrasty the V-ray distance texture. So with this little trick we will have more exponential decreasing of the opacity for the flame tails, and we still can adjust this graph for the output map as well. All we need is just to find the good balance between the brightness, the visibility of the flame tails, the colors, just like you want to see your flames. And now let's make a final render, final check in the frame buffer. Okay, good, but before we will jump to the preparations of rendering of the whole sequence, we will go through the all parameters of my simulation just to fix our finishing point with all these values, especially like time scale, cooling, the fluidity and steps per frame. We don't have anything in full. Rendering settings are like this. Our graph, we don't have a smoke. For the fire, our graph looks like this. The map inside the texture is output, and is inside this output we have a V-ray distance texture with the nozzle object as the target. Okay, and go next to our objects. The line has this size and the position, so actually it starts right at the edge of the nozzle. Next, let's check the final values for our follow path. The values are like this, you can see. The fire emitter, the only thing we adjusted is velocity, is 4500. The rest is by default. Plane force helper, the settings is on the screen. And the last thing is nozzle and our emit object. Take a look at the size difference between these two. It's very important. So this is it. On the render we have a little problem with the light leak from our fire voxels that is applying some light on outer surface of the nozzle, and to fix that we need to duplicate our nozzle object and give a name a render nozzle. So this one we will actually render for the camera. Let's make it bigger and with some gap to our voxels. Also, let's close this hole with the cap operation. In case if in your project you have you may have already animated a certain model with the engine of your aircraft, then you need to consider this issue, and for simulation you need to create slightly smaller nozzle, so you will not have this problem with the light leak. So we created these few boxes to imitate our engine. Also, let's deduct from the rendering our simulation nozzle, and just make sure that our render nozzle is fine. Also, let's deduct from the rendering our emit mesh and hide it. We don't want to see it on the render. Now let's try to render and see if the problem is still here with this light leak. Yes, the problem is still here, but further adjustments we can do with a parameter inside the visualization settings, light resolution. It will make render engine more precise with our cache, so the problem is getting less, and with the 50% it is completely gone. To double check that everything is fine, we can create a light V-Ray light, just a simple disk, and place it somewhere behind the engine, so we can see the light shade over our nozzle and boxes. Just make it invisible and hit the render. Yes, now it looks correct. We don't have any light leaks from our fire to the surfaces of the engine. Let's check a full frame rendering to make a final check that everything is correct. This is our final jet fire simulation, and this one with some light post-production adjustments. If you are willing to learn more about this topic and recreate this my scene with an engine fire test with all additional effects and dynamics like nozzle vibrations, lock chains, and make an ignition and turning off simulations, you are welcome to the video description, where you will find a link to my Patreon, where the masterclass Max Rocket Science will be released in a few weeks. So subscribe to my Patreon page so you won't miss it. Masterclass will include all articles covering everything from initial simulation and scene layout to final render and post-production, and additionally a final max scene. Well, that's all for now. Thank you all for your attention. Leave all your questions in the comments below. See you there. Bye.